Good day, everyone, and thank you for joining us for today's webinar. Today's webinar is entitled Top 5 Lessons Learned in Deploying AI in the Real World. We're going to be joined today by Roy Kim, Deep Learning Solutions Lead for Pure Storage. Roy, thank you for joining us today.
Glad to be here.
Before we get started, we have a few housekeeping items we want to go over. First of all, if you're watching this presentation, you're also going to see some poll questions pop up during the presentation. We'd like your feedback so we can get a better understanding for where you are in your AI journey and some of your thoughts around artificial intelligence, deep learning, machine learning, all those technologies that are really dominating a lot of headlines today. Second, if you have questions, please ask them using the questions pane in the GoToWebinar control panel. We will be answering questions during the event, and we really do mean it when we say we want questions. If you have any questions at all about AI, about how Pure Storage is tackling AI, about the role of storage in artificial intelligence, please ask the question, and we will do our best to answer that during the presentation. We like a lot of engagement from the audience. We're here for you. And at the end of the event, we'll be giving away a great prize, and we hope you stick around for that because we're really looking forward to seeing how people use the drone we'll be giving away at the end of today's event. And with that in mind, I'm now going to turn it over to Roy to talk about deep learning of artificial intelligence and some of the lessons learned as Pure has been out there in the world deploying infrastructure that supports organizational artificial intelligence initiatives. Take it away, Roy.
All right, thanks, Scott. Well, thanks for joining us today, everybody. Again, my name is Roy Kim. I'm the AI and Deep Learning Solutions Lead for Pure Storage. Just to introduce myself, while I work at Pure Storage, I don't have a storage background. Before my job here, I spent 8 years at NVIDIA building out their HPC and what became the AI practice. So I know quite a bit from the application layer all the way down to the infrastructure. Today, I'm going to be focusing around infrastructure and just go beyond the euphoria in some sense about what AI is being portrayed as in the public eye, and really get down to the nitty-gritty on what customers are running into when they deploy real AI infrastructure. So at Pure, we have helped many industry-leading companies deploy AI systems, including one of the world's largest supercomputers dedicated to AI and some of the world's most renowned brands for autonomous cars. So over the next 30 minutes or so, I'll be going over what we learned with these customers. So just to pop up at a really high level, many of us have heard about AI. There may be some skepticism about if AI is really being deployed in industries. And the fact of the matter is, it's still in the early stages, but it certainly is revolutionizing virtually every industry. And the reason why is because every industry benefits from intelligence, right? So every industry, no matter what industry you're in, can benefit from having greater insight or greater intelligence. Some of the examples that you see on the slide, like autonomous cars, are something that's in the forefront of everyone's minds. For example, Volvo and its subsidiaries, Annuity, have publicly announced that they're going to put production cars on the road by 2021 that's fully autonomous. But there are other examples that you may not have heard of and are quite surprising. So for example, Blue River is a company that recently got bought out, I think by John Deere. And what Blue River built is an AI robot that helps crops, and particularly in the farming of lettuce. In fact, 10% of the lettuce that's harvested in the US today are harvested by LettuceBot. And the way that works is that there are smart cameras in front of the tractor that determines with high accuracy whether that sprout is lettuce or weed, and therefore can really pinpoint their pesticides or whatever it is to that particular thing. There are other quite great examples of things that can change humanity, like healthcare. Mayo Clinic talked about how they are using AI to figure out what the genetic markers are within brain tumors. So today, if you know anyone that's gone through this very traumatic experience, if they have brain cancer, then they have to go through intrusive surgery where you have to dig in through the skull to get some tissue samples to figure out what the genetic markers are, then to figure out what the medication to use. The question is asked if you can look at MRI images and figure out, particularly, are there genetic traces that you can find through these MRI images, and Mayo Clinic was able to do that. So AI is certainly in a lot of industries, if not everywhere. Now, the impact is bigger than these use cases. Some would argue that this is going to be yet another tremendous shift in the computing industry. And to illustrate that, I have two cartoon examples. The first, which was on the left, published years and years ago, and it talks about the number one programmer's excuse for slacking off. And you see the two developers just kind of playing around, playing sword fighting, and the manager says, "Hey, get back to work," and their excuse is that my code is compiling. Recently, they published an updated version of that cartoon, and the number one excuse for slacking off is not because the code is compiling, but that the network is training. Or I thought that was pretty funny. But what that shows is that there is a sea change in the way that developers are expected to write code. In the past, it used to be experts who are experts in that domain, and they would write what's in their heads into algorithms through languages like C, C++, and so on. Now, you don't have to be a domain expert. You certainly need to know what you're doing, but in the end, software is writing software through lots and lots of data. So this is Software 2.0 is what Karpathy, one of the leaders in AI, has called it. Now, so that kind of lays a foundation for AI. But the question that's on, I'm sure, your minds is, why is a storage company even talking to us, right, about AI? So let me answer that question before we get into the top 5 reasons or things, lessons learned. So we have to really go back to what started the Big Bang of AI, and it's mostly agreed upon that there are 3 things that converged to bring about this tremendous energy in AI. First is deep learning algorithms, right? So deep learning has been around for a long time, but it was in 2012 when it really came on the world stage and blew people away with its performance and accuracy. And what you see there is results in ImageNet competition, where before 2012, the blue dots represented expert handwritten software for computer vision, and the y-axis represents the accuracy that it was able to deliver, and the green dot represents deep learning algorithms, right? And so you see that in 2012, it completely blew the competition away in its vision accuracy, and then over time, it just overtook the entire competition itself. Right, so that's one thing. The second thing that came together is the realization that massively parallel compute processors like GPUs can do and can run deep learning, right? So massively parallel computing architecture is the second ingredient. And the third, of course, is the availability of lots of data. It is said that data is more valuable than oil, according to The Economist now, The Economist magazine, and that's certainly a huge valuation in some sense that every company is sitting upon. And so these 3 things, deep learning algorithms, GPUs, and lots of data, right? Those three things came together to really fuel this AI revolution. Now, while these are interesting and these are critical technologies, they're not what you deploy, right? What you deploy are very different. So, for example, you don't deploy deep learning. You deploy frameworks that help you design networks for deep neural nets. Right? You don't. Secondly, you don't deploy GPUs. You deploy servers that host the GPUs. And lastly, you don't just deploy big data. You have to put it somewhere, and that's storage. And so the platforms that you need, that you tangibly, physically deploy, are these three things. So having said that, it could be argued that the most important out of the three, the most important out of the three is data. And so I think you could have a credible argument for whether deep learning algorithms is the most important or the GPU is the most important. But certainly you can make a credible argument that data is also, if not the most important. And the observation is made by Professor Andrew Ng, who is one of the luminaries within the field of AI, with a simple chart, but really tells a story as to the most important characteristic that separates AI or deep neural nets from other learning algorithms. What you see here is the x-axis, which is the amount of data, and the y-axis, which is performance. And in this case, performance you could think of as accuracy of the model itself, right? So the red line shows every other machine learning approach. And so as you add more data, as you apply more data to the learning algorithm, it grows in accuracy, but at a certain point, it tailors off, it plateaus in its accuracy. What we find is that with deep learning, that's not the case. As you add more data, as you apply more data to the model, the accuracy continues to grow. And in fact, it could be said that we still haven't hit a plateau in the amount of data that we're applying to these AI models today. So that really is the critical difference between deep neural nets and other machine learning algorithms. And in fact, is also a critical difference between usable technologies and not usable technologies. So for example, think about Siri or think about Google Voice. If the difference between 99% accuracy and 90% accuracy is huge, right? So 90% accuracy with Siri would be 1 out of every 10 words would be wrong, as opposed to 99% accuracy is 1 out of 100 words would be wrong. And that difference is really the cutoff point between what's usable and not usable. So, I went through the background as to why data is important, why storage is important. I'm going to get to the 5 lessons learned now. And so I'm going to pull a quick poll up, and it looks like it's already up already. I'd love for you to answer them. The question is, when do you or your organization plan to start your AI project? And you can select one of the...
While we have this up on the screen, I've got a couple questions for you. So
yep.
One of the things that when we start talking about AI is there's a lot of variations or evolutions or revolutions of AI we can talk about. AI is a huge category, but we've already talked a little bit about in this event about machine learning and deep learning. What are some of the nuances the basic nuances people should understand between AI, machine learning, and deep learning specifically?
Sure. I could give you a long answer or the short answer. The short answer is that AI is really the overall word that encapsulates machine learning and deep learning. It's really a huge discipline of thinking about how machines think like human beings. And so that can be computer science, could be in there, that could be philosophy, ethics, all those kind of disciplines could fall into AI. Machine learning is really the computer science discipline of AI, right? So computer algorithms that help that learn based on data, not explicit algorithms. And deep learning is a subset of machine learning where it's a very specific approach in the way that you develop these networks. And so that's how I would think about that.
Perfect. It's one of those things I've been asked a lot, so I thought it'd be important for people to understand. You want to see some results?
Great. Yeah, let's go over the results. So it looks like, thank you for everyone that's voted. Many of you have voted, and it looks like, well, there you go. So 33% will start the AI project in the next 12 months. It looks like 7% have already started, and another 17% is getting started now. So this is great. And another third is not planning to start AI project, which is great. You're here to learn. Great, thank you for your participation. Let's go to the 5 lessons learned. The first is that AI is not just a single application. It really is a series of applications that add up to deploying a real AI neural net, and it could be thought as a pipeline, right? So let me dig into that a bit more. So when the backdrop on this is that when you think about AI and when you survey popular press to see what defines AI, you'll probably see a mix of these types of information. First, you'll see new capabilities, amazing results that AI brings to bear today. So you'll probably hear things about AlphaGo and how it was able to beat the world's champion in an impossible game of Go, right? So that's what you typically hear. You'll a lot of times also hear about frameworks, and that's important, right? So because that's how you get really into and develop your deep neural net. And a lot of these frameworks are driven by hyperscalers or large web companies. So for example, Cafe2 is supported by Facebook. MXNet is supported by Amazon, though it came from Carnegie Mellon. Amazon is pushing heavily on that. PyTorch is also from Facebook, and TensorFlow is from Google. And you may have heard of like Microsoft Cognitive Toolkit, otherwise known as CNTK, that was developed out of Microsoft. So you'll hear a lot of that. And the last thing is there is a tremendous amount of euphoria around GPUs and the essentially new type of processor called the GPU. And the reason why is because while other processors like Intel-based or x86-based CPUs are serial optimized, GPUs are massively parallel, just like neural nets. And so you see a lot of the excitement around that. But if you're doing AI today, it is so much more. So for those of you who are data architects or data engineers who have deployed AI for a living, this kind of chart resonates with you more. And this is straight from a paper that Google published in 2015, and the title is Hidden Technical Debt in Machine Learning Systems. And essentially they went out to, the goal of this paper was to help us understand some of the pitfalls when going from these quick wins that you may have with AI and deep neural nets to deploying for real-world workloads. The paper shows in the end that the machine learning code is a small fraction of the real-world machine learning systems. So the boxes that you see on the right, the small black box that you see in the middle, in size represents the amount of effort or investment that goes into the code itself, and all the other boxes representing things like data collection to labeling to data verification to infrastructure management to monitoring, you'll see that all of that is really what is required to get AI in production, right? So it really is a seminal paper in helping practitioners go from just Sandlot working on their own machine learning stuff out of ImageNet to applying it to their workloads today. So if we were to organize all those boxes into a simple data pipeline, it would kind of look like this. And in fact, this particular design is true for every single customer that we work with doing AI. So every single customer has at least 4 stages in the pipeline or more, but at least 4 of these stages. First is the ingest stage. The ingest stage is when you take data from external sources into the training system. The data is typically stored in its raw form. Even when the label is added, it's really backed up in the raw form, right? And then the next stage is cleaning and transforming. This is where you modify the data, you save the data in the format that's convenient for training, such as linking a data sample to labels. And today we are still in the most part in supervised learning era, and so the data set that you have has to be labeled. And a lot of that work is typically done with lots of CPUs. The next stage is exploring. So this is a really critical stage where a data scientist may take the data that's already clean and labeled, and they have some model with some parameters, and they kick off a job, and they see if the job is trending in the right direction, if the model is converging in the way that they want. And so within that hour, they might look at how it's progressing. If it's not going in the way that they want, then they kill the job and they rerun a different job with different parameters, right? So this stage is really about quickly iterating your models. And then typically the last stage, although there may be more, is once you have a model that you feel is good to kick off for days or weeks, then you put that into a production GPU server farm, right? And so the end result of this is that a model would converge, and you could put that into production, whether it's production cars or production software as a service or whatever product that your enterprise is working on. Now, what you see is that there are different needs and different kind of stages and applications for each one. And there are also these silos where the data actually sits, right? And they typically sit in different storage units. And this becomes one of the biggest production inhibitors for data scientists, is waiting for data to copy from one silo to the next. And the question is asked then, why do you have to put all these data into different silos in these stages? And historically, the reason why is because each one of these stages have very different need for storage and for data hub or data lake, whatever you have there, or data warehouse. Right? So, for example, in the ingest stage, the access pattern is really about sequential writes. And mostly large files, although there could be a lot of small files as well. As you go on to different parts of the stage, if you go to the far right, we're in the training stage, you'll see that it's actually completely opposite, right? It's not sequential as in the ingest stage. In training, it's random. Access type is not write, it's read. File sizes are not mostly large, it's mostly small in the training stage. So what you see is that the pipeline for machine learning exercises the entire spectrum of a design point for storage systems. And as you can imagine, you really cannot design a storage system for everything. And so you put different data warehouses for each one of these workflows. Right? And I do want to point out that random access is extremely important for training. And the reason for that is because you really don't want to put any input or artificially put any biases towards your neural training, right? So imagine that you give your neural net the same set of data in the same sequence every single time. It will bias that learning process a certain way. And so that randomness is extremely important. Okay, so that's number one, that AI is a data pipeline. It's not just a single application as many people think. And there is a challenge in that data layer that most customers are stuck on. They're not stuck on the GPUs, they're not stuck on TensorFlow. They're really stuck on the management of that data layer. And I'll get back into how we were able to solve that problem. Okay. So the second lesson learned is that you shouldn't throw your data into a data lake. Okay, so let me talk about it a bit more as we go on, but I do have another poll question to ask. So there you go. There's a poll up. If you guys can participate in this poll, I'd love to share the results with the rest of the audience. So the question is, where do you store your data for your analytics? Whether it's AI, if you're doing AI today, or you're doing Hadoop or Spark or Splunk or Elastic, any types of analytics that you're doing today, where does your data sit?
So, Roy, as you're working with clients and customers and everybody around the world on some of their AI projects, where do you see them? Where do you see the biggest stumbling block that people actually experience? Yeah,
so the biggest stumbling block, it's really hard to say which is the biggest because there are so many things that are new when they're thinking about AI as opposed to any other workflows. So for example, some of the challenges could be just building out a data scientist team, right? Just data scientists are at least the good ones, are really hard to come by. They're expensive to hire, and so on. I would say that maybe not the most preeminent, but the one that comes up always first is what infrastructure should I build, right? So where do I get started is really the question that I get from customers quite a bit. And the reason why is because you really have two options, and I'll get into one of the lessons later on. You could do it in the cloud or you could do it on-prem. And on-prem, there are some things you need to think about, and so that's probably the one question that I always get from customers is, where do I get started? Okay.
Let's close the poll and take a look at the results.
Yeah, let's look at the results. Great. So number one is data warehouse, which means that the data is already structured from some unstructured pool of data, and it's sitting there, which makes sense because a lot of the teams are using things like SQL and Hive and these types of applications that require data to be already structured. Number two, besides don't know, is data lake. That seems a little low to me, 12%. I'll bet there is more than that, but the data scientists on the call probably don't have to interface with data lake. Essentially, data lake is the thing that supports data warehouse. Okay, so this is great. Let's keep going. So as I mentioned, while a lot of the data that the participants here talked about is stored in data warehouse, what's back-ending that data warehouse is typically a big pool of unstructured data, right? And that's typically called a data lake. And we've been taught as an industry to throw all of our unstructured data into this thing called a data lake. But there's been a sea change in kind of a perspective on whether data lake is the right way to go forward or not. And here's a great example of a quote from PricewaterhouseCoopers, is one of the leading consulting firms for this. And they're now calling it a data graveyard. And the reason why is because now that customers have dumped everything into HDFS, now they're asked to do something about it, and it's really hard to pull the data back. Now, I'm going to have to go through some historical lesson or context on why that is. So let me talk about where data lake and data warehouses came from. If you could trace the genealogy all the way back to about 15 years ago when Google published their now seminal paper called Google File System. It was so important that it inspired the creation of Hadoop and HDFS with their MapReduce paper the year after, and therefore spawned off multi-billion-dollar industry, right? So if you look at that paper and see what are the fundamental assumptions about Google file system, and therefore all the Hadoop file system implementations that were built afterwards, you'll see that their assumptions about big data are that files are typically large, right? So files are in the gigabytes range. The access pattern is sequential, right? So they specifically call out the fact that in the Google file system, they designed their system around the fact that I/O is sequential, and that data is batched. It's not real time, right? And so amongst other things, and so these are the assumptions that drove the building of this Google file system and the Hadoop file system. What it essentially looks like is a bunch of white box servers with lots of disks in it, right? And that really made sense because of the assumptions that they made about data, about big data, right? So assumptions being large file sequential access. Well, disks spinning disks are really good at that, right? Data is batched and not real time. Well, spinning disks are really good at that, and so totally makes sense in the way that they built out their infrastructure. But today, the modern data analytics, as we know of it today, changes everything, right? So a decade ago, really the only preeminent big data application was Hadoop. Now there is a plethora of applications that cover anything from machine learning to message passing to MapReduce to micro batching, and what we believe what happened is that while Hadoop was a great first start, it didn't cover what big data actually is. Right? Big data is not just large files. It's not just sequential access. It's not just batched. It actually happens to be that data in the real world are also small files. Data in the real world are mostly random and almost always real time. So what happened is that because Hadoop and the file system underneath it wasn't able to cover that, there became an explosion of different applications to cover much of the holes that Hadoop wasn't able to cover. And so, and on top of that, elastic infrastructure is extremely important. That's what cloud requires and developers require today. And so that's a historical perspective on what happened between Hadoop and essentially now people believe Hadoop is kind of legacy and all the new kind of applications that are available. So what does this mean in terms of data lakes and data warehouses? Well, in the end, what you have is a data lake, right, which is a bunch of disks for cheap storage, and you have HDFS that kind of manages all the data. But then you have these data warehouses, right, where you may have a data warehouse for Spark, and you might have a data warehouse for Oracle, and you might have a data warehouse for TensorFlow. And the data moves back and forth between the data lake and the data warehouse as they clean the data, right? So in the end, if you step back and think about all the applications that your enterprise needs to support, it really becomes sprawling and complex, right? So lots of redundant data copies, still built in the end, the underlying infrastructure is really built for large sequential data, and therefore you have slow performance, it's batched, it's not real time. And there's a lot of things that are wrong with building your modern analytics, and particularly AI, on old assumptions about infrastructure and data lake and data warehouse. So that's really the lesson number 2, is that be careful when you throw your data into the data lake or data warehouse. The underlying, you shouldn't just assume that the data is in good hands. In fact, more likely it's not, because it's built out of old assumptions. So lesson number 3, cloud or not to cloud, right? So that's one of the most frequently asked questions that we get from customers, is whether we do AI in the cloud or not. So here's poll question number 3. Bring that up. So we'd love for everyone on the call to participate on this poll as well, to see what everyone else is kind of thinking on the call. The question is, do you plan to use public cloud for your AI initiative or your analytics projects? Do you plan to use public cloud or some on-prem data center? Okay, great. I see that a lot of you are voting. Mm-hmm.
While people are voting, when you think about some of the more interesting projects that you've worked on with customers from an AI perspective, without naming names, what would you say is what would you say are some of the really great business outcomes people are experiencing through their AI initiatives?
Yeah, that's a great question. I may have a slide on this later on. One of the customers that have been public about the use of AI for their work is Zenuity, and I talked about Zenuity in the first couple of slides. They're a subsidiary of Volvo and Autoliv, and the exciting thing is that there's a lot of waste that happens with with cars today, right? And a lot of people are sitting in traffic because for artificial reasons, and so their goal is to increase safety and environmental pollution by putting self-driving cars on the road by 2021, and underlying all of that is AI and is using the pipeline and GPUs and our product. And so that's for me, self-driving cars is a really interesting area where AI is being used. Okay, great. So actually, okay, there you go. Results. Wow, this is surprising. I don't know if it's surprising to all of you on the call. I would have actually thought that there is more people using public cloud than not, but it looks like that many of you, some of you, about 8% of you are using 100% public cloud, while most of you are using some or mostly on-prem data center. So let me actually, that's great. That's great insight. I actually didn't expect that. Thanks for participating. Let's go to the next slide and think about how we suggest to customers when they think about AI. Really, the short answer to cloud or not to cloud is it depends. It depends on what your organization, where the organization is in terms of cloud initiative, where you are or where the data science team is. But for the sake of simplicity, let's say you are either in one of two camps, right? You are either in the exploration stage in AI or in the production stage for AI. So if you're in the exploration stage, you're really just getting started in this journey. You're going to try not your own data sets, but publicly available data sets like the ImageNet data set or the YouTube data set, just to learn and ramp up, right? And so you may start to apply some of even your own data sets with transfer learning, and that's the exploration phase. In the production phase, you're really beyond that point, and then you've gotten to know neural nets, you've tried it for yourself, and now you're starting to apply your company's data set to integrate the learnings of AI into your products. And the need for in production is really to get the intelligence of AI models into your products faster than your competition. As opposed to an exploration, it's really just to get started. Now, while that's the need, what about the don't need? Well, in the exploration stage, what you really don't need is to be bogged down by infrastructure, right? You really just want to get started. If you're in the production stage, what you don't need is to be bogged down by cost or performance, right? And so because you really want to get to the market faster than your competition in the most cost-effective way. And so the high-level recommendation is, if you're exploring, then just go with cloud. It's simple. You have a credit card, just do some publicly available data sets. But if you're gonna use AI in production, then on-prem is the way to go. And let me show you a quick chart on the cost, and I'll talk about performance. So this is comparing cost of NVIDIA's DGX system, which is their GPU server with 8 GPUs in it, The server that I'm looking at right here is based on Volta GPU, which is our latest GPU. And if you purchased a DGX with Pure's product called FlashBlade, let's say it would roughly cost about $300,000, right? And it will get you to do training for your AI network 24/7, and it's going to be blazingly fast. Now compare that to the cloud. In this case, it's AWS EC2, and they have a particular instance called P3.16x large instances, which also is based on the Volta GPU, so very much apples to apples comparison in terms of performance. It would cost about $24 an hour to run your job in the cloud. And so you can imagine that as you ramp up in the first year, you're going to save money by running in the cloud. But as you continually run your training job, just right after the first year, the cost equation flips, and so it becomes more expensive to run the cloud. In fact, after 3 years, you'll have 60% savings in cost when you have an on-prem solution. Right? So it just goes to show that it really depends on where you are in your journey. If you're doing AI regularly and you're running training workloads on a regular basis, then you need to have this in mind in terms of the cost trade-off. And then, of course, the performance trade-off is the other part of the equation. I'm going to venture and just say that DGX plus FlashBlade is going to give you much faster performance than anything in the cloud. And the reason why is because it's fine-tuned for the highest performance, and in the cloud, you really don't know what the network backend is and how fast the S3 storage system is. So there are a lot of unknowns in the cloud. Okay, so lesson number 4, benchmarks, lies, damn lies, and benchmarks. While benchmarks are extremely important, they could be misleading when you're thinking about real-world AI infrastructure, and let me show you why. So let's take ImageNet as an example. It's probably the most popular publicly available data set. And a lot of times customers come to us and they say, we ran ImageNet and it's telling us that we should buy this kind of infrastructure. What do you think? Well, we go back and say, well, you have to, what is your real world workload like, right? So what do I mean? So if you look at ImageNet and the underlying assumptions about data in it, versus, in this case, comparing against the real world autonomous car company and their needs when they were looking at speccing out their infrastructure, they're quite different. So, for example, in the image size, the size of the data itself in the ImageNet is roughly 150 kilobytes per image. For a car company, these are high def, JPEGs or images or videos, and they're going to be in the megabytes range, not kilobytes. The file size is kind of interesting. The way that ImageNet does their benchmark is they pack a bunch of images into a single file, right, into a TF record. While that's interesting, in the real world, you wouldn't do that because you want to randomize your data access as much as possible. So you want to access individual files as you train. And then the mode of testing is interesting. In ImageNet, most people test their benchmark using synthetic mode, which has no I/O. It doesn't exercise the pipeline. It doesn't exercise the network. And of course, that's not how you would typically do it in the real world. You would actually read from storage and you would use your network and so on. Right? So you have to really be careful when you're thinking about speccing out your infrastructure of course, you want to use these benchmarks. You want to supplement that with real-world assumptions. So let me get into some benchmarks. Now that we're talking about benchmarks, I didn't get a chance to introduce our product. I'll do that in the last minutes. But in this case, I will show you that our product is the white box that you see on the bottom right-hand corner. It's called FlashBlade. And so let me talk about these 3 scenarios that we're going to show some numbers around. The first scenario in the benchmark is this synthetic mode, as you saw in the ImageNet in the previous table. Essentially, the test is seeing how fast GPUs can go, right? So you're creating synthetic data on the fly in system RAM and just shoving it into GPU as fast as possible. So that's number one. Setup number two is using real ImageNet data, but putting it into the system RAM, right? And so the data is sitting in RAM, and it's going through the entire workflow that you see on the top through the CPU, which does the decoding and scaling, and the GPU, which does the evaluation, the forward and the backward prop. And the third setup is real data sitting in FlashBlade, going over the Ethernet network into the DGX system and training the network that way. So you see those three setups. Let's see how it compares in performance. So very interesting data. So let me walk you through this. What you see is are three networks that are quite popular. ResNet 152, ResNet 50 from Microsoft, Inception, I think that's from Google, and those are three networks. And then the y-axis is images per second. That's essentially the throughput of the training benchmark. How many images are going through the forward propagation and the backward propagation. What you see on the bottom is number of GPUs. So from 1 to 2 to 4 to 8 GPUs, up to 8 GPUs fit in a single DGX. And then when you get to 16 GPUs, that's 2 DGXs. And then if you go to 32 GPUs, that's 4 DGXs. Okay, so that's the background on this. The red bar shows the performance of the synthetic mode, scenario number one, where the system is just generating random data on the fly and it's feeding the GPU as fast as possible. And so you'll see that it's kind of scaling at a near linear scale. The blue bar is data sitting in DRAM, right? So literally sitting right next to the CPU and the GPU. And so what you see is that it's a little slower than the synthetic benchmark, right? And part of that is because it has to go through the CPU, and sometimes the CPU is bottlenecked. The green bar is data sitting in FlashBlade, going over the Ethernet network into the GPUs in the DGX system, right? And what you would have assumed is that would have been much slower than the other two. But what you see is that because FlashBlade, as I'll get into later on what it is, it's essentially built for AI and for modern analytics, and therefore can keep up and sometimes even perform incrementally faster than data sitting in DRAM. So that's really the benchmark that customers want to do in a single box, 2 boxes, 4 boxes, DGXs, scaling with Ethernet network. Okay. So then lesson number 5, what is the ideal platform? The ideal platform is a data hub. So let me explain what that is. Data hub is built around the idea that analytics is not just a pinpoint solution anymore. It's a data pipeline. And in the data pipeline, you really don't want different silos or different data warehouses. You really want a single platform where all the data sits. But as we talked about, the challenge behind that is that each one of these applications have different needs on the data, right? Some applications need sequential access, large files. Some, applications in this case, like Spark, needs near real-time performance. TensorFlow in this case needs small file performance. And so that's fundamentally a challenge with data warehouses and data lake. But what if there was a way to build a single platform where all your data sits and eliminates all the data copying back and forth? And that's essentially what we built at Pure Storage with FlashBlade, and is the reason why essentially most of the large customers that are doing AI in production today are working with us or are talking to us. And the reason why is because it really is the industry's first to build a storage system around this idea of a data hub. it's built to do all kinds of access type really well, from small files to large files. It's built to do random access well to sequential access well. It's built to do all kinds of workloads really well. And the reason why, the fundamental technology and architecture that allows that to happen is that we built from the ground up a system that's massively parallel. And that's an important point, because every storage system that's in the industry today, as well as data lakes and data warehouses, are fundamentally flawed in that they're full of serial bottlenecks. Whether it's on the software stack or the hardware stack, there are lots and lots of serial bottlenecks. And what Pure Storage has done is built a system that took almost 4 years of engineering to do, because we fundamentally believe that the future is massively parallel. And it just happened to be right bet, as you know, that today AI is driven by massively parallel technologies, right? So whether it's neural nets or GPUs, they're massively parallel, and therefore you would expect the data platform to also be massively parallel. And that's why Pure Storage and FlashBlade was awarded the best innovation in AI hardware this year at one of the world's largest AI conferences. And the recognition here is, I guess the question is how can a storage system win best innovation in AI hardware? And the recognition is that those who are actually doing AI today, right, those who have their hands dirty and trying to get this stuff to work, is they understand the fundamental challenges of managing data. Right? And so that's the problem that we solve with FlashBlade. So let me show you an example of a real customer that has done this. This is Man Group, and Man AHL is a subsidiary of that. So Man Group is the world's largest publicly traded hedge fund company. And the AHL division is using systematic algorithms to make trading decisions. So essentially, they're not having humans make decisions, they're having computer algorithms make decisions. And so you can imagine that their infrastructure and the compute is their differentiator, right? And so they're really pushing the limits of analytics. And what they have is a combination of a pipeline that includes AI, as well as Apache Spark, as well as MongoDB. And in the past, what they used to have is a silo for each one of these stages in the pipeline. And moving that data back and forth between silos was one of the fundamental productive bottlenecks. What they have built is a new infrastructure with a FlashBlade that supports all the compute services that are sitting on top of that, whether it's AI or Apache Spark or some database application. They have a single hub that supports all their needs. And not only that, you can imagine that brings simplicity. Not only that, the icing on the cake is that they were getting significant performance boosts, in some cases up to 20x increase in their Spark workloads. So those are the 5 lessons learned. I hope you had a great time just going through that with me. AI is a journey, and whether you are in the beginning of that journey or well into the production part of the journey, I'd love to talk to you. If you have any questions, I'll put them in the chat window. And thank you for being on the call with us today.
We do have one question. What are your thoughts around what this person refers to as bare metal cloud? How do you feel it compares in terms of performance to public cloud, and how does that make more sense than on-premises if you want to go that route?
Yeah, bare metal cloud is also kind of interesting. It depends on so there's two angles to that. There is the cost angle and there is the performance angle, right? So bare metal cloud will definitely give you better performance than the traditional services that's sitting on top of instances in the cloud. But as you know, because the infrastructure needs to be well tuned from compute to network to where the data sits, it's not going to be as performant as something that you have on-prem, that you have control over designing. And the other angle to that is of course, is cost. you still have to in the bare metal cloud, you still have to pay for the instance, pay for the I/O, pay for the storage system, and so you have to, it depends on where you're at, but the cost equation changes wherever you're at in your kind of AI journey.
And we also have a prize to give away before we end today's webinar. Are you ready for us to do that?
Yeah, let's do that.
All right, so we are giving away a Mechamon AR-enabled BattleBot drone, which actually looks really cool. And our winner today is Bill Norton. Bill, we'll be reaching out to you after the event today. Roy, thank you very much for this incredibly informative webinar. I think this was invaluable information for our audience.
Well, thank you for having me on.
And thank you to our audience for joining us today, and we'll see you next time.